Good morning, guys. Today we are learning about n queens problem using backtracking. In n queens problem, we use n queens, n rows, and n columns. We use queens in chessboards. You know the queen rules in the chessboards, right? The queen can move straightwards, rights, and diagonals, right? Let me explain briefly. See, take a 4 by 4. 1 minute, guys. Take a 4 by 4 chessboard. You have like 4 columns, 4 rows, and don't use this. Now place a queen over here. Queen can move towards this side, and the diagonals. Now you have to take a new column. Before taking a new column, you have to see that the queen should be placed in the safe place. As you can see, this place is danger zone and this is danger zone. You can see that this place is quite safe zone, and this place is also quite safe zone. Now again check the positions, check the attacking places of queens. You can attack like this, you can attack like this, you can attack like this, you can attack like this. So these 3 places are the danger zone. Now if you check, this place is not the danger zone, but this queen, no, I have said you before that no 2 queens have to undergo attacking move. No 2 queens has to attack each other. This is the main principle of this n queens problem. No 2 queens has to attack each other. These 2 queens can attack each other. So you cannot place your queen in this block. So backtrack. When you backtrack, you have to place the queen position. You can even place the queen position here. No, you have to place here. Even this is the safe zone. This is also a safe zone. Now check the queen's positions. You can move like this, you can move like this. So these 2 are the safest places. Once place the queen over here. Now check this queen cannot attack this queen cannot attack this. Check the positions of the queens. This queen can move diagonally and straight. This you cannot place any queens over these 3 positions. You can only place the queen over here. But if you place the queen over here, this queen can attack this queen. So no 2 queens has to attack each other. Now let me draw it more clearly. That is 1 2 3 4 5. So you all know we have already placed the queen over here. This queen is not satisfying, so backtrack. When you backtrack, you have no place to keep your queen because already these 2 places are danger zone. This place is also danger zone, so you cannot put your queen anywhere in this column. So backtrack again. You have already seen that these 2 are danger zones, and this were you have already backtracked this 2 here. So no place for the queen over in this column also. Backtrack again. Now if you see, this queen can move 1 step forward, right? Move 1 step forward. Check the queen's destructive mode positions. You can only place a queen over here because 3 places are like danger zone. Now check the queen's positions. These 2 are danger zone and these 2 are the safe zone. If you put the queen over here, this is the danger zone. If you put the queen over here, this is the safest place. Now check the queen's positions. These 2 are the danger zone. If you see, this queen cannot attack over here, this queen cannot attack over here, this queen cannot. So this is the safest place. Queen, if you want to represent through matrix form, the vacancies should be zeros. The vacancies should be zeros, and the queen should be 1. You can represent the queen as 1, 0 0 0 0 0 1 0 1 0 0. This is the n queens logic behind this n queens. Now if you see the algorithm, once read this. The n queens is the problem of placing n chess queens on an n into n chessboard so that no two queens attack each other. The following is the solution for n four queens problem. See, we have already solved that, I guess, just now. You have seen the same queens and the same matrix, right? See, you can represent through ones. See, the expected output is in the form of matrix that has ones for the blocks and where queens are placed and zeros are the vacancies. The time complexity of n queens problem is order of n factorial. Now if you see the algorithm of n queens problem, following is the backtracking algorithm for solving the n queens problem. Initialize an empty chessboard of size n into n. Start with the leftmost column and place a queen in the first row of that column. Move to the next column and place a queen in the first row of that column. Repeat step 3 until either all n queens have been placed or it is impossible to place a queen in the current column without violating the rules of the problem. If all n queens have been placed, print the solution. If it is not possible to place a queen in the current column without violating the rules of the problem, backtrack to the previous column. Remove the queen from the previous column and move it down one row. Repeat step 4 to 7 until all possible configurations have been tried. This is the code implementation for n queens problem. You can see that board n row, this is rows and columns and column. If all the queens have been placed, then return true. If the queen is placed in the safe place, then it return true or else false, and again iterate. This is for loop, no? You can iterate again, come backtrack. Actually the concept is backtracking, no? You can backtrack and again backtrack. If it is false, again backtrack. If it is true, print. That's it. This is the code implementation of n queens problem. Thank you. Please like, subscribe and share